try and hit the highlights. He's a technical specialist with Autodesk, has been there since May of 2007. Previously was with Perkins & Will for 11 years as a project manager and an implementation specialist for BIM systems or building information modeling. He was a chair to 2 firm-wide initiatives, was an IDP mentor for young architects. He's a member of AIA, NCARB, and the USGBC, and has worked with local communities, or his local communities, to establish a sustainable neighborhood approach to development, integration, and support to facilitate best practices. Based in Chicago, we're very fortunate to have him here for the day, and he's a Tennessee grad, so he may not be aware that the ACC is the better of the 2 conferences. So make sure you let him know that today before you please welcome John.
All right. So I'm not tied to this mic, though. I'm just tied to one of my, all right, good. I like to walk around, and I think I'll be loud enough. Can you hear me in the back? Yep. It's kind of tough sometimes standing behind a podium, I think. Well, I did live in Charlotte for 8 years, so I do know a little bit about ACC. Had to work up at NC State as well as Duke and Chapel Hill. Basketball, obviously, is wonderful here in the Carolinas. Certainly, I saw that, but yes, SEC does rule in football. I'll leave it at that. But we seem to not be able to do much. Florida, though, as you've seen in the past, have done pretty well in basketball. Tennessee, our program still isn't up to par with the Carolinas. All right, so to get started, just from a standpoint, this is an AIA accredited course. So these are the rules and regulations. It also gives a credit for the USGBC as well. So in recognition of that, some of the learning objectives for today, just to cover briefly, how are we on time? 45 minutes. All right, so in the sake of time, I think some of you may have already seen some of the learning objectives, but predominantly what I want you to understand after today's presentation is simply the use of technology, perhaps the use of building information modeling, of how this can actually help improve the way in which we look at projects in a retrofit and a renovation environment. I'm going to give you some workflows, some techniques of how maybe we can look at how to bring existing buildings into this context. Once we do so, how we actually can look at elements and tools that are in place, whether they're on the cloud, the web-based environment, or they're on your desktop. There are probably things they're using right now, or perhaps you're not using. But with that, I'm not going to reintroduce myself from a standpoint of I am John Beams. These are the 3 topics that I'm going to cover, so this is really the agenda side of things. I don't really have to cover, per se, much around the industry movements. Besides, on the side of technology, yes, I will. But speaking to a USGBC chapter is a little different to going into a community or environment where, we'll say it's in Des Moines, Iowa, that sustainability is not big. So sometimes you got to talk at the level for them to understand, but not at a USGBC chapter. I'm not going to skip over it by any means, but just in recognition of your expertise and your knowledge in this room far outweighs sometimes where I do have to give this presentation. As I mentioned, I'm going to provide some data workflows, some ways in which we can look at an existing building context. Understand this does work certainly well for new buildings, but this is maybe just a different view and a different way to utilize technology from an existing building standpoint. And then I'm going to introduce some of these tactics and some of these workflows specifically to address sustainability, to address energy, to address energy use, as well as maybe even look at how this articulates itself to LEED daylighting credits. Please feel free to ask questions throughout. Certainly based on our time, we've got 45 minutes. Sometimes I do talk fast. If I talk too fast, please let me know. I'll slow down. First thing I'd like to address in the industry is climate. I'm not going to address climate change by any means, but I want to address how the use of technology can actually help us perceive what a project could do, whether it is in an existing building environment or it's a new building environment. How do we actually know what the weather could be? What are the wet and dry bulb temperatures? How do we get this information? How is it derived? Well, if we look at the world, this is the way in which we categorize different climate zones. And then specifically in the West, what we see is a map of the Western United States. It's in part, but specifically there are red dots on here. These red dots represent mostly airports, sometimes it's high schools, but these are weather stations. This is where we get our weather data. Well, traditionally that's where we get it. However, there are now elements of weather files that exist throughout the world, 1.4 million weather files to be exact, that are more up-to-date weather files. These are weather files in which you can use on your projects today. So the grid that you see on the screen, it is an overlay throughout the world where it is a 20-kilometer grid where these data points are actually measured in elevation. TMY2 files, which are the ones we get from our airports, sometimes called an EPW file or TMY3, they don't actually provide elevation. So if you're actually working in Asheville and you receive a weather file from the Asheville airport, or maybe you even get it from somewhere else, it's typically not even going to have elevation. So the elevation is actually a nice key factor to these weather files. So specifically in Charlotte, I simply just have the address of where we are right now. And it may be hard to see in the back, but everyone does get a copy of this presentation so you can laugh or whatever you want to do or share it with people. But what you'll see later in articulation, here's the project being the project address location. Well, surrounding that are 4 weather files. I don't know why I'm shaking. I never shake. But right here, right here, right here, right here. Well, what you would see, regardless of where this project is, you would see always the TMY2 file, but more importantly, these weather files that actually are potentially better for your use right now on the existing building context. Obviously, that weather information can then be derived in the use of a building information modeling, specifically if you're looking at wet and dry bulb type scenarios. To then take another step to look at weather in a different way. All these weather files, we typically look at them in a CSV or a comma-separated format, such as Excel. But there are tools in place in the industry where you can actually look at this from a visualization standpoint. So in this case, I think I'm looking at this is solar radiation of a particular weather file. So this is not for all. Trust me, not everyone would utilize this type of information being, I need to really study the weather. But there are tools in place, and I see quite a bit of people using it. Second topic on the industry movement would be around resources. How we actually know what resources buildings are looking to consume, whether it's the water, the energy, even down to the materials in which we're selecting. For the sense of harvesting of materials within 500 miles, how do we actually know this? Well, there are tools in place where we can start to allocate energy consumption, water consumption, photovoltaic potential on projects by simply utilizing the capabilities inside a building information model, also the use of some web-based tools that I will introduce later. This is simply a look at a solar radiation study done on a very conceptual model. This model you'll see throughout the presentation. This is Autodesk headquarters. It's 111 McGinnis Parkway out in San Francisco. But in this case, it's a very simple model, which I try to tout from a standpoint. It is very important to be simple with the models in which you want to work with in the efforts out to even energy modeling, as you will see in a moment. You're going to see more of these results, but this is actually the project I particularly ran here in the location where we sit. But we start to drill into the information that is important to us. Where we start to look to make improvements or where we make recommendations on projects, where we have the opportunity to do alternative measures to the project. Specifically, I think the use of water on a project, I think we're going to be looking at something much, much different when 189.1, the ASHRAE new edition that it comes out, where it's a large focus around water conservation and water preservation. So this would be a tool where it actually estimates your water use. But to say that I don't want you to be detailed in the model, you actually don't have one water closet, one fixture, nothing that actually is an element that it could define. It's knowing it from the building context, the building construction, its location based on where you tell it in a GPS coordinate system. So water becomes a benefit. The last topic would be around comfort, how comfortable we are in this space in the museum, or how comfortable we are where we have the opportunity, such as at home, to raise the window for natural ventilation. How is it that we actually know this? A lot of it stems from the weather file, in which we can utilize as a part of the BIM workflow, as a part of looking at weather. But then more importantly, as we have this context of a model, how do we know what the daylighting factors are going to be in a space prior to it being constructed? So there are certainly tools that are used in the industry. Radiance is one of them, Radiance being a free tool that a lot of lighting designers do in fact use. So the workflow out to Radiance is quite simple if you're doing this all in the sense of building information modeling. Some solar radiation tools and shade and shadow tools, if you're using BIM, you know this, but to be able to capture what it looks like from a shade and shadow scenario is already inherently part of the building information modeling platform. The ability to determine heating and cooling loads from a design of a project is achievable also inside the building information modeling environment. So how comfortable it would be, how you can actually assign the systems inside the model before it's built, I think is a very nice capability, as well as moving forward as to looking at that weather file a little deeper to even look at heat gains for the building. Just different analyses can be done in the use of that tool. Now this lastly addresses something based on the time. I'm probably not going to be able to show it, but I have a video where it goes in depth, where a building information model is connected to desktops from a standpoint where it's starting to measure temperatures, where it's starting to measure relative humidity in spaces. This is tied to the building information model, but it's actually in real time, and this is just a screenshot of the AVI. We called it Project Dasher. This is Autodesk headquarters, one of the Autodesk headquarters in Toronto. So if we do have time, I'd like to show it, but I don't know that I'll have time. So as I move away from the climate resources, and I want to touch on some trends that are happening. Some of those trends, these are the trends that you all are tracking and knowing and know very, very well. But how this actually equates to then the opportunities that service providers, that owners, that contractors actually can have in the retrofit and renovation environment. McGraw-Hill has done some wonderful studies on this back to 2008 and obviously 2009 as to owners not only looking to make energy improvements, but then specifically, I'm going to even talk about an example that the USGBC now has, where you want to look at it from a performance contracting standpoint, but then to overlay that this group would be interested in green performance contracting, how we actually go in and renovate under a performance contract, but then holding to the feet to the fire, being the contractor or the service providers that actually perform the work. So myself being an architect and getting those credits every year for your CEUs in an architecture environment, as well as maintaining your registration. One of the things that I don't see a lot, but I think should be addressed, and that is the definition of sustainability from an AIA perspective. It's just, anyone can have the perspective that they want on what sustainability means to them, but to meet an HSW SD credit, you actually must address this definition. So meeting the needs of the present without compromising the ability of future generations to meet their own needs. A lot of words. What that means to me is that I want my little 5-year-old Ridge and I want my little girl Sage, age 2, to enjoy what I got to enjoy growing up. Because we have that opportunity now. We know that, I mean, look at the 117 people in here. You guys are part of this movement, as well as everyone outside the door is a part of this movement. But that's what's most important to me, and I know that just one component of it is technology. The larger component is our heart and our brains and the way in which we actually conduct our daily lives. So about a year and a half ago, the USGBC published this book, and I brought one copy, and anyone can come and browse it, but I did give it to Bo because he was interested. Reason why I point out this book is the USGBC published this from the owner perspective, from an RFP perspective around green performance contracting, and how we actually look to incorporate the different technologies, perhaps. That's only one small component, but it's how we actually write a contract as a part of that. Well, per my relationship with the author of the book, I had made a recommendation to look at the use of BIM. Not to look at an Autodesk product, but actually look at the use of BIM for its capabilities downstream into energy modeling. Lo and behold, he actually put it in the book. And I thought it was a good thing from a standpoint of the USGBC. I'm also working on elements with USGBC of what's coming ahead of, I can't say too much, but what they have on their API down the road, where we actually might start to look at integrations of different platforms into the lead rating system, where we actually might be able to do this. But this specifically addresses GBXML, Green Building Extensible Markup Language, and how this actually can be beneficial to get downstream into a train trace, a HAP carrier, eQuest, etc. It's I plagiarized. Obviously, I photocopied or PDF'd it and highlighted. So again, it's an owner perspective, but in here, it talks about the incorporation of BIM. And then it also talks about GBXML, and it does highlight some products, and I can mention the products once the presentation is over. So specifically around performance contracting, who in the room is familiar with performance contract base? So we've got a few of us. So what I did of an investigative study of what performance contracting is when I worked at Perkins & Will, I was actually not involved in any project, I don't believe, that actually dealt with performance contracting. It's a different element, not to say architects aren't involved in it now. I saw it more on the engineering side. So they break their projects up a little differently than we would in an SD, DD, CD type environment. But the interesting thing to me was reading the article about the Empire State Building and actually how they made the decisions of what improvements they wanted to make on this building. They did it from site visits, walkthroughs. Eventually what they did is they created an energy model, but they do this all really from a, let's say, a plan-based environment or an elevation-based environment. Maybe go through and articulate that this facade we want to change out all the top floor windows to low E, where the bottom floor we're actually going to use a different material. That's how they would decide on a performance contract base. So it's typically what we do. It's the drawings, the plans, the elevations. But where we could fast forward is if we incorporated the use of building information modeling in this preliminary analysis phase. The contract phase is really kind of where a lot of service providers, architects, engineers would do their articulation and their mapping of what actually happens. However, in the preliminary analysis stage, this is an opportunity where we can start to look the incorporation and the use of building information modeling, whole building energy analysis that ties itself to then the energy audit that is being produced as a part of the preliminary analysis. So BIM, who in the room is using BIM currently? Hands a little higher if you don't mind. All right, good. I couldn't tell. So the use of BIM I do see as a movement. When I did start my tenure of architecture here in Charlotte, it was with Perkins & Will. At the time it was Nixman Shive Perkins & Will. Sounds like a law firm. We all have kind of been through that. Answering the phones was a nightmare. However, it then became Perkins & Will. One of the first things I had to do is to start to utilize this sense of CAD. Atlanta was using it, but Charlotte office wasn't using it at all. Mr. Phil Shive and Jim Merriman, they were drawing by hand still. Also, Michael Hill was in there. Well, one of my first tasks was actually to take this tartan grid, design grid, and actually replicate it in the sense of CAD. This was my introduction to seeing someone that was very well versed in design from the Louis Kahn days, to then articulating how this is actually done in CAD, to taking a leap forward to putting it into 3D. Really kind of blew Phil and Jim's mind. To now fast forward to where we are in the BIM movement, of how this idea, this technology can move from floor plans, ceiling plans, elevations to one model, one file, and to be able to share that with an entire team, maybe even across the country or across the globe. Being able to do this in this environment is incredibly is an incredible feat, maybe. All right, in this one file, for those in the room that are not utilizing the sense of BIM, one of the key capabilities within it are the ability to visualize. Because everything is in one model, at any point you want a perspective, section, you name it, it is there. It's also relevant that it's in any schedule that you want, door, window, etc. So from the design aspect all the way through the document aspect to also even simulating what's going on in this environment is all within the framework of building information modeling. I thought USG did a wonderful thing, and this is probably 5 years ago. And I like equating it back to my days actually in Carolina when I had to go to the Department of Insurance, and you've got to have your UL 905 wall labeled correctly on that life safety plan in the beginning. And then in those days, we actually would take the orange books, photocopy it, and paste it on the front of the drawing sheet. Well, now actually through the use of even USG, where you can actually draw those blocks, elements, families, cells, whatever you need into the BIM model, that would have made my work a lot more easy back in the day. But now moving on to construction, a very large benefit when we actually have designed and conceptualized the idea, but now actually how we build the project through the use of building information modeling is a very large benefit. All right, so I'm going to move into some workflows and some incorporation of how we might utilize BIM early on, to then maybe taking a step into a detailed look of how we actually use this information of GBXML. This perhaps might be some workflows that we could look at from an existing building context, whether we're going to start from paper or pen and paper or DWG, DGN, PDF. But to be able to look at this from a project team scale, to then getting into energy analysis and creating this energy model. Really, during my tenure at Perkins & Will, there was never once a time that we created an energy model. That was always handled by our engineers, and it was something that we gave them tons and tons of PDFs or DWGs so that they could then go and build it. But now having the capabilities inside the building information modeling platform is now I've seen turn in firms. Doesn't have to be a large firm, doesn't have to be a small firm. All firms are starting to see, if I have this opportunity to create something called an energy model, maybe I can learn more about the project. So what I'm going to introduce is a workflow called rapid energy modeling. And the rapid aspect is how quickly can we get a conceptual model and derive some results on it based on form. Maybe that form is from Google Earth. Maybe it's from photographs that we take of the building. Maybe it's from existing plans. There's a way, there are many different workflows that we can derive as to how to actually get these existing buildings into a building information model. And I'll highlight in one path. But in this workflow diagram that I've presented on the board here, this is going from the use of pictorials, had a little of a CAD overlay, and this is going to be a particular project that I'm going to show, to then utilizing the concept level of BIM. There's even tools now that are available to us that are web-based tools in the BIM environment, and they can be introduced even at a senior level designer, someone that doesn't need to get into the weeds in a BIM environment, but one that actually can look at it from a conceptual level design, to being able to run a conceptual energy analysis inside the platform itself, where it actually goes out to the web, does a analysis based on the DOE 2.2 engine that it uses, and then brings back the results inside your building information modeling platform. It does give you this ability to calibrate things. It makes assumptions based on it being an office environment and lighting power load density is 1.01. Well, we know from a lighting power load density of walking the building and talking with the facilities manager, it ought to be around 1.5. So you can actually change your power load densities as need be, and that is from a calibration sense that we actually want to try to get this model as close as we can to, let's say, what is actually happening in the building. This new introduction of dashboards, being able to look at a large number of buildings or projects that you're working on, you actually now can visualize it in a dashboard sense. And as I already mentioned, eQuest is one of the energy modeling applications that is used in the industry. So there's a path to eQuest. There's a path to Energy Plus. There's a path even to Train Trace. So this rapid energy modeling approach we saw this type of workflow influence in many, whether it's from the owner side, from the tenant side, or the building design team, where they actually could learn something about the project in which they're embarking on. This one, what I've done is I've just kind of said in a high level what these projects are. This is actually a customer up in the Northeast where I delivered a presentation to them 2 weeks ago, where they're looking to incorporate this rapid energy modeling approach in a pilot scenario where they have a lot of existing building assets. And they're also looking at the new asset rating that ASHRAE will be coming out with. And what they wanted to do is compare what they could see from the building information modeling sense. Very quickly, the team that I had within Autodesk to help me do this, these are the results from capturing the buildings from Google Earth and pulling them into a building information modeling environment. So this is square footage that was provided to us by the owner of these particular buildings to then what we were able to capture without going and visiting the site. And I'm highlighting this project because the project I typically highlight is we Autodesk actually did this for all of our buildings throughout the world, where we did it from photographs. This one is a different tangent where we actually did it from simply the cloud or the web, where we actually went onto Google Earth and Google Maps, where you actually can look at the buildings. From that, we were actually able to create these pilot projects for a dormitory, city hall, office complex, and a courthouse. The two pieces of information that they did give us was for the office and the courthouse of their actuals. So this is where it gets pretty interesting as to what we get reported from a whole building energy analysis to then what is actually being paid by the owner on a yearly basis, finding out where the demand is and seeing if our demand from the analysis side actually matches up. They didn't have the records to give to us for the other two projects, but the office and the courthouse. And then this is specifically energy use, so they from the utility bills and looking at the electricity. So this is just simply some of the results that we looked at from the courthouse, the dormitory, and actually what we had to do to change assumptions. But what I'm going to try to articulate in what was done within this work, the time frame was less than 2 weeks on all 4 of the buildings to be able to get the results in which we got pretty darn close to what they were actually having from a demand side to actually the utility bill side. To this owner, it was not of great importance on the side of cost. It was more about their EUI and actually getting the EUIs to actually align with something that is articulated simply from a very conceptual building model. We're able to present some results just within the building information modeling environment and platform. Some of you have actually maybe used this tool, but this was the owner really enjoyed being able to see this all up front. And then the dashboard is where they can start to look at all the buildings in which were a part of this pilot, but then moving forward, how they're going to get the remaining 115 projects that they want as a part of then what would be called, in fact, a dashboard. So a little around how we do that. From the capture standpoint, pretty easy, pretty cut and dry that we actually take a plan, we could go and trace that plan, we could click on the walls, make those walls now a 3D element. That's pretty simple from a drawing standpoint. A little more detailed, laser scan. This is Autodesk Waltham headquarters, the AEC headquarters outside of Boston, where laser scan was done. And it was done by Tachi Builders. It's the contractor that we selected to do the project. This is an example of what Tachi utilized as a part of the laser scan. And I think it's a nice way of saying, what are they going to do with the laser scan? Well, first they wanted to test it against actuals, being the square footage. We actually learned some things, that the square footage that was listed and leased for was greater than what was actually measured. So they took, Kling Stubbins was the architect, they took the existing 2D DWGs, created a BIM model of that, and then this is the comparison against the laser scan. And this is specifically highlighting the floor levelness of what was said in the as-built documents versus what is actually built. And we know how that is in the field, and concrete doesn't get leveled quite as nice as we would want it, but that's okay. So, but this is, Tachi used it from a standpoint of when they started to do the work and build the buildings. They did this from a material standpoint. So when they actually started to lay out the partitions that were all done from a laser. They had no shop drawings on it. This helped them justify and understand the material use on the project. Now this is what we did as a study from a photograph standpoint. So there is technology in place where we can photograph a building, put points on this photograph, and eventually make a conceptual model that may look like this. Very, very rough, rudimentary. We wouldn't use this to then articulate windows because we would use the building information model, so very quickly we would bring it into a building information modeling environment. This is a specific example of 111 McGinnis Parkway out in San Rafael, where it's a little more than 3 photographs, what you saw in the other example. This building is kind of down in a valley, so it actually took a few more photographs to stitch together to make this very conceptual building form. This form looks like this in a very rough, rudimentary way. Another ability, as I've already addressed and touched on, is satellite imagery. Sometimes we can obtain this whether it's from Google, but we actually have other means and methods, and that's what I've actually done in the project that I referenced in the Northeast. To being able to get this information rapidly and into a building information modeling context to then do a conceptual energy analysis is quite easy. So I'm going to take you through that, and I know I'm probably running, I got 15 minutes. That's perfect. BIM. It all starts from the use of building information modeling. All the tools out there that market themselves as in the use of building information modeling, all of them have one thing in common, and that is they can write GBXML. GBXML, it can come in many flavors, but specifically GBXML is what drives how we utilize the conceptual energy analysis tools, how we utilize a train trace environment, an eQuest environment. It's how we actually can talk to the energy modeling tools. XML is something that is on every web page. We know what that is. Well, this is just the way in which our industry, very similar to IFC, how we can communicate with other applications. GBXML is kind of the designated element of direction where we can talk to the energy analysis tools. Some of the components that you can put into a BIM model are categorized on that last slide, but then more importantly, when you are very simple about the way in which you're modeling, do know that you can actually set construction types, U types, R values as it's in context to the project, but then also specific to each individual space and or facade of a building without getting highly detailed. The USG example, going out to their website and grabbing one of their blocks or cells or families and putting it in your environment is not useful until we're starting to document, because we have the authoring tool that can tell the wall what it is. It's a 4-inch wall, and it could even be a millimeter wall. We could actually make its assignment from a U value standpoint. This has the opportunity to write into the GBXML schema. This schema derives, this is what I did is I created a project, again, here in Charlotte, and I took a baseline example, then I went and made some of the calibrations that should be done, let's say, from an office environment, because it assumed some lighting, power, and load densities that I didn't need. The schedule, I just simply thought from a standpoint of it being an office environment. I chose office as its schedule. I chose 12-5, 5 days a week, 12 hours. Maybe that ramps up in the early afternoon, so I have the opportunity to change scheduling as a calibration element reference. Again, this is kind of the front end of when you actually are creating this type of environment on the web where you're going to utilize the Do2 engine to run your performance calculations. It gives you this screen where, if from an owner's perspective, you might actually be able to buy down utility costs. So you might be able to manipulate these, or you have the opportunity to manipulate these numbers, but these are based on the North Carolina average. All of this then is the derivative of what you will see in a moment of results. But do know that you actually can calibrate and or change the price of kilowatt and or therm on a particular project. So my point a moment ago, a lot of competitors write GBXML. This particular application that you can use on the web only accepts GBXML. So regardless of what you're using to author your building information model, once it writes GBXML, you actually can utilize this portal to then push it up and utilize this web-based environment. So I ran, again, the USGBC baseline, and I'm able to start to look at some results. I can find out how many kilowatt hours are being spent on this particular office location that I put in downtown Charlotte. It is the 111 McGinnis Parkway building. It wouldn't fit right here, but that's not of importance. What is of importance is, if you think about this, I was actually telling Bo this before the presentation, on a prototypical type environment. Had a meeting a couple weeks ago just north of here in Charlotte, but where I live in Chicago, McDonald's, I can say something about McDonald's, where they do have prototype designs, and they have many of different locations that McDonald's reside in the world. So having the opportunity to take this prototype design, test it against the different weather stations, to then derive from it, from a prototype design at conceptual level, to understand what's the difference in the use of therms or kilowatt in this location. Now you start to look at the balance of materials. So I'm going to change, although the the prototype says I must use this wall, maybe I do need to start looking at a different wall construction or roof construction for that environment in Alaska versus Florida. They're using the tool currently to actually determine that when they're looking at new prototype locations. I already addressed it earlier, but the water usage is something that is just inherent once it does the calculation and the analysis. What I like to point out is you actually have the opportunity to change. This is wonderful from an existing building context, that you know you have 10 fixtures in the building or you have 50. Just making one change to making them low flow, making the urinal waterless, what does that do to my water consumption? You have the opportunity to change the assumptions that it was for the fixtures of the water closets. One of the other prerequisites of a HSWSD is actually to address one of the 10 Committee for the Environment measures that the AIA put forward. This one particularly around photovoltaics. You have the opportunity using this tool, this whole building energy analysis tool, to look at the potential for photovoltaics. It understands every surface, the roof, the exterior walls. It is not telling you where to put these panels, but it's giving you the opportunity to see if it's something you may want to achieve in this particular climate. It also does the baseline calculation for the LEED 8.1 daylighting credit. It is not enough for the documentation efforts for the USGBC. What I mentioned earlier of myself working with the USGBC moving forward, maybe it will. I don't know. They'll tell me. They'll tell our division and the authors of, let's say, the building information modeling environment. However, this is a great first look. Can I start to look at this credit as it is associated to my project if this is one of my project goals? Design alternatives is a part of the use of this tool. Base run, it doesn't have occupancy and light sensors in the building, but that's an immediate thing we want to do and an important thing we do on all of our projects now moving forward. Well, just simply being able to put that in as an alternative. It could be in the model, but here we actually can change that as a design alternative. We could rotate the building if we need be. That's really only important on a type of a new building or a prototype maybe design. But this is where we have the opportunity to change out HVAC systems, rerun the analysis, and actually see the results. So we can actually compare the results, whether or not maybe it's in a dashboard or just in a quantitative way. This is all exportable to CSV format. One of the other measures that I like to touch on would be sustainable design intent and innovation, specifically around energy modeling. I've said it a couple of times, but the important underlier of how we actually derive this information is because we utilize what the Department of Energy created some years ago, and that is the DOE 2.2 simulation engine. That is utilized in Energy Plus, that's utilized in eQuest, and then this web-based tool also uses that engine to derive the results. So what it gives you the opportunity to do is to convert where we were in a building information modeling environment, regardless of its extension, the GBXML I now can convert into the file formats that are acceptable into eQuest. So very rapidly, I've been able to get from a conceptual level, from satellite images, conceptual level model, to an environment where I've learned something about the energy consumption, water consumption, to directly putting it into an energy modeling tool. This is where it's important, where we put the actuals in. These are the tools that are kind of in the industry that are standard, where you actually are starting to compare your actuals to what the building design intent was. kind of a highlight that, yes, not only is it utilized in the design aspect, the conceptual design aspect, the documentation, construction aspect through the use of building information modeling is all the way down even to the subcontractor base, where they're using this virtual environment to plan what's actually going to happen with the work. In this case, this is the Waltham example of our office, the headquarters, where this is the contractor, where he didn't use TPM, but he used someone to print out images of what this bank of, for instance, offices is going to look like. That was all done from the BIM model in and of itself. They met every morning in the subcontractors' meetings in this digital environment. That's how they actually performed what they were looking at from a standpoint of coordination. One element that I like to start to introduce, and that is from the facility side and the operate and maintain side. Models, if created in the environment of a building information modeling, have the opportunity to hook up to our BMS and the EMS systems. We have a Living Labs experiment actually in Waltham. So this is the live building of our headquarters outside of Boston, where it is hooked up to the Johnsons and the Siemens controls of the world. You have the opportunity in a web-based environment actually to see what's happening in that particular office, turn the lights on or off. It's really kind of interesting. So in conclusion, I hope that I've been able to expose you to some maybe new workflows, some new ways to be able to capture an existing building, but more importantly, how we can actually learn something, some elements from what we captured as a part of existing buildings through the use of energy analysis tools and conceptual energy analysis tools moving forward. So I'm going to end with a project, and I mentioned it earlier, and that is the Empire State Building. But what I'm going to tell you about the project is actually nothing on the bullet upgrade list here. It is that when Rocky Mountain Institute, Johnson Controls, and the design team were pulled together to be a part of this project, they went back and forth as to what it is we want to do to improve, changing out the windows, changing out the HVAC. Once they actually determined what they were going to do, it then took them 8 months to verify we're going to do this. Why I say 8 months is it took them 8 months to utilize eQuest. eQuest is a free energy modeling tool, by the way. It took them 8 months to create the Empire State Building in the eQuest modeling environment. So now having the opportunity to work with Rocky Mountain Institute and seeing how you can actually incorporate from a BIM environment, maybe from a pictorial environment, an as-built environment, to eQuest, I have a feeling they could have saved a few months in the formulation of the 8 months that were spent. So with that, I'm going to open it up to questions. Yes?
You mentioned calibration of models and benchmarking that against utility consumption. How do you account for, or how do these products account for not only kilowatt hour consumption, but also for demand? Because you've got to balance both of those aspects on a day-to-day basis, as well as consumption and demand.
Yes. So the question is, how do you balance the demand side in a building project in the formulation of kilowatt hours? The way in which you do that is to actually understand the building first and foremost, and to see if your results from a equipment power density and a lighting power density, as well as the selection of your HVAC. Where we do see a larger differential is actually on the therm side when seeing the results. We saw this in our San Rafael as well as our UK example, where our results from the conceptual energy model were far, far outweighing what we are actually using. So it takes some site visits to really, truly understand, or a call to the facilities manager. That's the way in which you can calibrate it at current. You have many different dials that you can utilize in the platform itself to make it where it's in the sense the true representation of the building. By no means is this workflow, the rapid energy modeling workflow, something that we're trying to get it to be 100%, because we want this to be democratized, that you can actually do this very, very quick study of buildings, and then it makes its way into the documentation and the construction phase. Does that help?
Yeah, more specifically, if you've got a steady load, say you got like you said, your 1.5 watt per square foot of lighting.
Yep.
that's only 24 hours, that's going to provide you a certain amount of consumption in a month. But if that value were lower in the evenings and higher during the daytime, you're going to have a demand, a KW demand that changes throughout the day.
So
there's two variables there that it's hard to tweak both of them at the same time.
well, from the results I showed you, you couldn't do what I'm about to answer. You can manipulate the schedule. So you can choose the different frequency of the schedule, whether it's 12/5, 12/7, it's a workshop, an office. But when you actually go into the building information modeling environment, down to each individual space, I actually can tweak the schedule per space. I can change the lighting power load density per space, as well as the equipment per space. That's when I get into the detailed side of it. You do have that opportunity. So doing all that work, then you export a GVXML, you now can actually use it and run it against the DO2 engine. More importantly, actually out into eQuest, because eQuest is where you actually truly do all the work.
So does the eQuest and the DO2 have the ability to put in the different tariffs or the rate structures that utilities, and some of them seem like, ratchets, time of use, all that type of stuff. I guess if you're done at that level, typically?
Yes. I'm more than positive eQuest, yes. We don't sell, no one sells eQuest. You just go and grab it off the Department of Energy's website. But yes, you can at that level get down to the nitty-gritty.
I think we're out of time, so John, if you have a few minutes to stick around in case
Yes.
has any questions, let's do that. And,
But last and most importantly, thank you. Thank you for paying attention, for enjoying, maybe enjoying, I don't know. You guys tell me, but I appreciate the invite. It was certainly nice to be back in Charlotte.